All right, welcome to periodic trends, our technical third concept in Unit 3. This will be a rather long video, as you obviously saw, but it's not too bad. A lot of it's just kind of sorting elements. So let's get started. A trend is a predictable change in a particular direction, like fashion trends. For example, those were the clothes that technically people wore when I was a kid, when I was junior high, high school. In hindsight, they're weird. Okay, maybe not so much high school, more like when I was, elementary school type status. But nonetheless, understanding trends and elements enables us to make a lot of predictions, enables us to actually, look at elements and get a better idea of what would happen when we react things. So, the first trend we're going to talk about is atomic radius. This is the average distance between the nucleus of an atom and its valence, or we also call that the outermost electron. So for example, here's our nucleus. This distance right here is our atomic radius. However, that's often hard to find because this represents a cloud, an area that things may be in. So typically we take two atoms, bond them to each other, and we find this distance. And ultimately what we find is that the distance between two atoms is half of the distance between half of the radius is twice the radius of each atom. So we take this distance divided by 2 and we'll get our atomic radius. Now atomic radius increases from top to bottom, so it gets bigger this way. And it decreases from left to right, which also means our largest will be on the bottom left and our smallest on the bottom right. Kind of a little picture of that. Kind of gets bigger as we go down towards the bottom left. That is our trend in atomic radius. So let's practice this. We need to sort these elements into increasing atomic radius. Now, I'm going to tell you that the smallest one, increasing by the way, means kind of going big, small to big. So that means the first one's going to be our smallest. And our last one will be our big. So I will tell you that our smallest is going to be francium. But I'd like you to pause the video and tell me what the rest of them would be. All right. Hopefully you've paused the video. And let's see, or you actually took time to do that. Our next smallest would be sulfur. Next one would be aluminum, strontium, and then francium. That's how atomic radius goes. Because remember, it's small at the top right and gets bigger as we go down to the bottom left. So we just put these in order of which one's closest to this and then to what's closest to the bottom left. That's atomic radius. Our next trend is ionization energy. It's the energy defined as the energy required to make an atom lose its valence electron. So it has electrons, we shoot this energy into it, and it pops off the electron. The first IE is the energy required to move our first electron. The second is required to move the second. You probably figured that out, but it's just, you'll see those phrases every now and then. The trend is that it tends to decrease from top to bottom and increase from left to right. So notice kind of the more red the color, the higher this is. So the highest is at helium and hydrogen, and it gets smaller as we go down. And it gets bigger as we go to the right, with the largest being on the top right and the smallest being on the bottom left, meaning it's going that way. And if we actually track them by atomic radius, you'll see helium is huge, and then it drops back down to lithium, which is over here. You'll see it build up as we go towards to neon, drop back down when we go to sodium. Both of these charts help, but really you can just remember that it goes this direction to get bigger. Again, I will show you the smallest, or we're going to increase in this time, so I will show you the first, and you will do the rest. So, in this case, our smallest is barium. Okay, pause the video, try and figure out the rest. All right, hopefully you have paused the video, and I'll show you what the rest of these are. After barium, we have, I believe, calcium. After calcium, we have silver. Actually, this thing may be in order already. And yep, it is. Well, that's kind of boring. That's awkward. Well, they're in order. Hopefully you know why, but it just happened to already be in order. Our next trend is ionic size. This is basically the same thing as atomic radius. Please keep that in mind. This is just atoms are when the electrons are the same, and once they give or take electrons, we're asking what happens to them. But it still is the size of that particle. So cations will have less electrons because they lose, so they get smaller. If you look over here, the the red over here and the blue over here is what the ion size is. The tan greenish color is what the original. So you can see all these positive ones. The red is smaller than the original. So cations get smaller. Anions get bigger. That's why the colored is bigger. Because they have more electrons. They take up more space. So when comparing ions, if multiple ions happen at the same charge, for example, the previous slide mainly dealt with charges, so a 1 plus is smaller, but a 2 plus is even smaller, and a 3 plus gets even smaller, just like a 3 minus is bigger than a 2 minus, which is bigger than a 1 minus. If they have the same charge, you just compare them by their original size, because notice, rubidium started bigger, and that means even after it loses an electron, it's still bigger than potassium, which is still bigger than sodium. So you just, if they have the same charge, you just compare them back to the original atomic radius trend. Lastly, ionic size tends to increase from top to bottom within a group. That's because the atomic radius is also increasing. And generally, the size of metal cations, so positive ones over here, and non-metal anions, which means negative ones over here, decreases from left to right. So typically that means that our first row tends to have 1 plus, and our second rows tend to have 2 plus, which the more electrons you give away, the smaller it'll get. And as you go farther to the right, we have higher negative charges, meaning they're taking more electrons, meaning they're getting even bigger. So it's a little more complicated, but on average, they tend to decrease going left to right. Let's practice this. Again, I will show you the first. Actually, I'll show you the first two. This tends to be a little confusing. Okay, so actually I'll show you the first and last. So the first one we're going to have, we need to find the smallest, actually this is decreasing, hope you noticed that. So we're going to find our largest first. That's going to be, if we're looking with ionic size, we're finding the one with the most negative charge typically. In this case, that will be phosphorus, actually silicon, which tends to have a 4 minus charge. And then we start decreasing in negative charges until we hit 0. And 0 is only going to happen with noble gases. Then we start doing positives, which start losing. And our smallest one is going to be Al 3 plus, because that's going to give away the most electrons. So pause it, try and figure out the rest of these, and I'll show you how to do them in just a second. All right, let's finish these. So we have phosphorus is 3 minus, sulfur is 2 minus, chlorine is 1 minus. We don't have any zeros, but we do have a sodium as a 1 plus and a magnesium as a 2 plus. Now, you actually should factor in their location on the periodic table, but all of these are in the same row, so we can kind of just go off the charges. So again, basically the bigger the negative charge, the bigger the atom, and the bigger the positive charge, the smaller the atom. There you go. All right, one more example. But in this case, I'm just going to show you the first one. We are doing increasing, so I'll show you the smallest. You'll notice when you look at the table, these are all in the same column, which means they all have the same charge. So we are just sorting them off our original atomic radius, which means our smallest one is beryllium. And that's because they're all 2 plus. So we just sort them off the original size. Okay, pause it, and you figure out the rest. All right. let's finish this. Beryllium, magnesium, calcium, strontium, barium. There you go. Again, if you want to put 2+, you can. That's ionic size. Okay, electronegativity. This is the ability of an atom to attract electrons from other atoms. Typically, you think of this as almost I know it's an arm wrestle, but a tug of war. The stronger the ability is, the more likely they are going to be able to take, or in this case, win a fight. This guy really doesn't stand much of a chance. His arm's kind of wimpy, like mine. So in other words, it represents the likelihood an atom will form an anion. So the stronger they are, the more likely they're going to take an electron because it's easier for them. The lower the electronegativity, the more likely they are to just kind of lose an electron. So let's see the trend. In general, electronegativity values decrease from top to bottom. Notice they're getting smaller. And for representative elements, which basically means you're not doing the middle ones. Let's see if I can draw. Nope. Trying to put a box over the D. So you're not doing these. That just really didn't work too well. So for all these elements, it typically will increase from left to right. And notice they do tend to get bigger. For the middle ones, they just change. We just kind of don't care about them too much. You may have to sort them. If I ever do have you sort these blocks, I just assume that it's going to increase this way and decrease this way. So let's try it. All right, again, I'll show you the first one. You get the rest. Decrease in electronegativities means we start with the largest, and the largest is fluorine. Pause the video. You get the rest. All right, welcome back. Let's go with the rest of them. Next one is oxygen, then phosphorus, then I know it's a transition metal, but still iron would be, if we're assuming the same trend, sodium, and francium. That's electronegativity, and that finishes our video on periodic trends. Rewatch any of these as you wish. These are the type of questions you'll be asked, given, just, sort these elements. Hopefully they're not too bad. Thanks for watching. All right, I have one last slide for you, and this is, if you're watching at home, this is the practice we'll do tomorrow in class. If not, I'd like you to take out a sheet of paper and start working on these problems. I will start putting practice at the end of videos, so this is probably the last time I'll actually have really explain what you're doing. But I'd like you to actually practice this. And this time, I would like you to get all 4 problems. There will be times where I'll say less, but for this time, go ahead and try all 4.